Now, this session we completely devote for the circles chapter, and all of you know the concept of a circle. Now, here see, rather than discussing the problem, the theory part, because you are very interested and it is very important on the problems part only. So, wherever theory is necessary, we will discuss, but we mainly concentrate on various types of problems on circles. So, problem number 1, 2 rods of lengths (2A and 2B) slide along x and y axis respectively, such that their ends are always concyclic. Then the center of the circle lies on the curve 1 x square minus y square is equal to a square minus b square, 2 x square plus y square is equal to a square plus b square, 3 x square minus y square is equal to b square minus a square, and 4 x square plus y square is equal to b square minus a square. So, that means, see here x and y axis are there, origin. So, suppose AB is one rod of length 2A and CD is another rod of length 2B. These two rods are sliding along the axis with the condition that A, B, C, D are always concyclic. They lie on a circle. Then we want to find the locus of the center of that circle. Right. So, let us suppose this is PHK be the center of the circle, so that M, and if you draw, suppose this is N. Now, you can have that is this is R and that is R. So, now please see. So, let PHK be the center of the circle. Now, draw PM and PN perpendicular to AB and CD respectively. Okay. And you know that in 10th class or 9th class, you learned that the perpendicular drawn from the center of a circle onto a chord bisects the chord. So everybody knows that right from 8th class itself. So therefore, AM is equal to MB, each is equal to A, and CN is equal to ND, each is equal to B. Okay. Now, from the triangle, you know that, so since triangle APM is right angled, is right angled, AP square is equal to AM square plus PM square, but that is A square plus H square, A square plus H square, sorry, PM square, A square plus K square, A square plus K square. Similarly, PC square is equal to, you are having CN square plus NP square. So this is B square plus H square. Okay, but AP is equal to PC, each is equal to the radius R. Radius R. So therefore, A square plus K square is equal to B square plus H square, or H square minus K square is equal to A square minus B square. A square minus K square is equal to A square minus B square. So therefore, PHK lies on the curve x square minus y square is equal to A square minus B square. So that is, so the answer is option 1. Answer is option 1 itself. Let's see, problem number 2. The length of the cord intercepted by the circle x square plus y square minus 10x minus 20y minus 44 is equal to 0 on the line 3x minus 4y is equal to 0 is 1, 12, 2, 16, 3, 24, 24. Right. So that means you are given a circle and a line. The line equation is 3x minus 4y is equal to 0. Suppose the line cuts the circle in the 2 points A and B, and you know that the center C of the circle is, and you know that for any circle x square plus y square plus 2gx plus 2fy plus c equal to 0, which is the general equation of circle, the center is minus g comma minus f. So minus g comma minus f means here 5 comma 10. 5 comma 10. And you know that radius is g square plus f square minus c. So here the radius is g square means 5 square plus f square means 100. 100 plus 25 is 125, and minus c means minus of minus 44 plus 44, which is 169. So the radius is 13. The radius is 13. Now you draw perpendicular CM. Now you know that C is equal to 510 and R is equal to 13, or the center and radius of the given circle. Now draw CM perpendicular to the chord AB. Chord AB made by the circle, made by the line on the circle, so that AM is equal to MB. So therefore, and now you can write that is, now CM is equal to the perpendicular distance formula. Now CM is equal to modulus of 3 into 5 minus 4 into 10 by square root of 3 square plus 4 square. You know the perpendicular distance. The perpendicular distance of a line ax plus by plus c equal to 0 from the point x1 y1 is modulus of ax1 plus by1 plus c by root over a square plus b square. So 3 into 5 minus 4 into 10 by square root of 3 square plus 4 square, which is nothing but, so 15 minus 40, 25, 25 by 5, so which is equal to 5. 40 minus 15 is 25, 25 by 5, which is equal to 5 itself. So now, so therefore, now 13 square, or I will write, now AB is equal to directly twice AM, so that is twice AM is square root of 13 square minus 5 square, 13 square minus 5 square, so which is equal to twice 12. So 13 square means 169 minus 25, so 144, which is equal to 12. So the answer is option number 4, 2 into 12, which is equal to 24. Generally, some people, they try this same problem in another method by solving the circle equation and the straight line equation. That means if you write the value of y in terms of x, that means y is equal to 3x by 4 in the circle equation, then you will get a quadratic in x. Solving that one, you get x values, that means which are the x coordinates of a and b, and from that you will get again the y coordinates of a and b, so you can find the length. But that is somewhat a little bit time taking process. But this is direct geometrical properties. The distance between the tangents drawn to the circle x square plus y square is equal to 9, which are perpendicular to the line 2x plus 3y plus 7 equal to 0 is 1, 3 root 13, 2, 3 root 3, 3, 6 and 4, 6 root 3. Okay, and you know that for any circle, if two tangents are perpendicular to the same line, that means they are parallel tangents. So this is, suppose the line is, the given line is 2x plus 3y plus 7 is equal to 0. Now he has drawn two tangents which are perpendicular to this line. Which are perpendicular to this line, and automatically the very shortcut method is very simple. The required tangents perpendicular to the given line are parallel. Hence, the distance between them is equal to distance between their points of contact. Distance between their points of contact means that line is nothing but a diameter. The distance is nothing but a diameter of the circle, because you know that the point of contact, from the point of contact, if you draw the line joining the line to the center, it is perpendicular to the tangent. Their points of contact, which is nothing but, which is the length of the diameter. Length of the diameter of the circle, and which is 6, because since 3 is the radius, so this is a shortcut method. Because see, the shortcut methods, for each and every problem, there will not be a shortcut method, because if there are shortcut methods, then the entire books will be rewritten. For every problem, you can write a shortcut method. But the shortcut methods are available only when you know all the properties thoroughly. You are thorough with the properties of the subject. So here, the fundamental property we have usually simply the distance between the points of contact is nothing but the length of the diameter. Now, usual procedure is usual method. See, line perpendicular to 2x plus 3y plus 7 equal to 0 is of the form 3x minus 2y plus some c equal to 0, because these two lines are perpendicular to each other. Now this line touches the circle if and only if the distance of the line from the center 0 0 is equal to radius 3. So this is 3x minus 2y, this equation is 3x minus 2y plus c is equal to 0. So that means modulus of 3 into 0 minus 2 into 0 plus c by square root of 3 square plus 2 square is equal to radius 3, or that implies c is equal to plus or minus 3 root 13. So therefore, distance between the tangents is equal to modulus of d1 minus d2, that is 3 root 3 minus of minus 3 root 13 by root over 3 square plus 2 square. So which is 6 root 13 by root 13, so which is equal to 6, itself. So this is usual, of course this is usual proof, but the previous one is a very shortcut, because if the property of the tangents, parallel tangents to a circle, it gives you the distance between the two tangents is nothing but the diameter of the circle. So using that property you did it. Of course that is a little bit time saving procedure, but this is a strictly usual procedure. This is problem number 4. The locus, the equation of the locus of the foot of the perpendicular, drawn from the origin, from 0 0 origin upon any line passing through the point 2, 3 is 1 x square plus y square minus 2x minus 3y equal to 0. 2 x square plus y square plus 2x minus 3y equal to 0. 3 x square plus y square minus 2x plus 3y is equal to 0. And 4 x square plus y square plus 2x plus 3y is equal to 0. Right. Here what he is doing is simply is taking a line passing through a fixed point 2, 3. And so many lines you will get passing through these. And onto these lines from origin is dropping perpendicular. Suppose M, N is dropping a perpendicular. Now he wants the locus of these feet of the perpendicular, M, N, N, M, N, and so many you will get like that. If the line changes, then the foot of the perpendicular will change. Now all these feet of the perpendiculars, they lie on some curve, and the curve equation we want to find out. Right. The shortcut method I will give you, very shortcut method. Suppose OM is perpendicular to the line. So since angle OMP, where P is equal to 2, 3 is 90 degrees, P must lie on a circle, on the circle, M must lie on the circle, for which OP is a diameter. OP is a diameter. So, but circle described on OP as diameter is x into x minus 2 plus y into y minus 3 is equal to 0. Because you know the equation of the circle drawn AB as diameter, x means of diameter where A is equal to x1 by 1 and B is equal to x2 by 2 is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. Here x1 by 1 is 0, 0. x2 by 2 is 2, 3. So x into x minus 2 plus y into y minus 3 equal to 0, or that is x square plus y square minus 2x minus 3y is equal to 0. So, which is nothing but option number 1. This is just because see, if you see this, two of the circle, this is 90 degrees and this is also 90 degrees. So, this M and N lie on a circle. These 4 points are concyclic. So, that means for which OP is the diameter. OP is the diameter. That is shortcut method. Now, I will give you the usual method. So, P is equal to 2, 3 and let M is equal to HK. Now, OM is perpendicular to PM, implies slope of OM into slope of PM is equal to minus 1. That is perpendicular condition. Two lines are perpendicular if and only if the product of their slopes must be equal to minus 1. So that is slope of OM means K by H into slope of PM is K minus 3 by H minus 2, which is equal to minus 1. So that if and only if K square minus 3K is equal to minus H square plus 2H. So that is if and only if H square plus K square minus 2H minus 3K is equal to 0. That is HK locus is x square plus y square minus 2x minus 3y is equal to 0. This is traditional method. This is a traditional method, and that is using the geometry, that is a complete knowledge of the geometry, because M is perpendicular, so this is a right angle triangle. So for that right angle triangle, this M is lying on the circle with OP as a diameter. Problem number 5. P is an external point to the circle S is equal to x square plus y square plus 4x minus 6y plus 4 cos square alpha is equal to 0. Now, if the angle between the tangents drawn from P to the circle S is equal to 0 is 2 alpha, is a 2 alpha, where 0 less than alpha less than pi by 4, 0 less than alpha less than pi by 4, then P lies on the circle whose equation is one x square plus y square plus 4x minus 9y plus 11 equal to 0. 2 x square plus y square plus 4x minus 6y plus 9 is equal to 0. And 3 x square plus y square plus 4x plus 6y plus 9 is equal to 0. 4 x square plus y square minus 4x plus 6y plus 9 is equal to 0. So what you are given is, you are given a circle and P is an external point from this is drawing the tangents, and all of you know that from any external point of a circle we can draw two tangents. Suppose O is the center and T dash are tangents, and because the entire angle is 2 alpha, so alpha, that is alpha and alpha. Now, the center of the circle is minus 2 comma 3 and radius of the circle is circle R, radius R is equal to 2 sin alpha. 2 sin alpha. So, therefore, now sin alpha is equal to, from the triangle, right, from the triangle OPT, sin alpha is equal to, this is OT by OP. So, which is equal to OP by OT by OP, which is equal to 2 sin alpha, 2 sin alpha by OP means h plus 2 whole square plus k minus 3 whole square under square root, where p is equal to h comma k. That's all. Now you got the problem. Sin alpha will cancel. So that means you will get h plus 2 whole square plus k minus 3 whole square is equal to 4, or hk lies the locus of, or hk, phk lies on the circle, x plus 2 whole square plus y minus 3 whole square is equal to 4, or that is x square plus y square plus 4x minus 6y plus 9 is equal to 0. So, that is the equation of the required locus. Now, the correct option is answer option 2. Now, problem number 6. This is 2014 mains. 2014 mains. Let C be a circle, C be the circle let C be the circle with center 1 comma 1 and unit radius and unit 1 unit radius. If T is the circle, if T is the circle centered at centered at 0 comma k, 0 comma k, passing through origin passing through origin 0 0 and touching the circle circle C externally, then the radius of T is 1 square root of 3 by 2, 2 root 3 by 2, 3, 1 by 2 and 4, 1 by 4. The solution is see you are given a circle with center 1 1, center 1 1 and radius 1 unit. Now you are given that a circle with center 0K, which is on y-axis. The center of the circle is 0K and it touches the circle the given circle externally and touches the given circle externally. So with center 0K. So now suppose this is B and this is A. So now let A is equal to 1, 1, the center of the given circle, and B is equal to 0K, the center of the circle 0K, the center of circle touching the given circle externally, touching the given circle externally. Now because it is touching, so therefore distance between them, the centers AB is equal to sum of the radii R1 plus R2, sum of the radii. So that means this is, and which is, but the sum of this radii is nothing but K plus 1. AB is equal to K plus 1. Okay. Or this is, that means, but AB is equal to square root of 1 minus 0 whole square plus 1 minus K whole square, which is equal to K plus 1, which is equal to K plus 1, or that is, if and only 1 plus 1 minus K whole square is equal to, so that is 2 minus 2K plus K square is equal to K square plus 2K plus 1. K square cancel. So this shows that 4K is equal to 1 or K is equal to 1 by 4. 4K is equal to 1 or K is equal to 1 by 4, which is option number 4. Please see here what the conceptual is, if two circles intersect and touch each other externally, if and only if the distance between the centers, their centers is equal to sum of the radii, that we have used. The distance between circle A, B is equal to sum of the radii. Here this radius is K and the radius is 1. Okay. So that is the concept of external contact of two circles. Now one chain 7. This is 2013 mains. The equation of the circle passing through the foci of the ellipse x square by 16 plus y square by 9 is equal to 1, and having center at 0, 3 is 1 x square plus y square minus 6y minus 7 equal to 0. 2 x square plus y square minus 6y plus 7 equal to 0. 3 x square plus y square minus 6y minus 5 is equal to 0. 4 x square plus y square minus 6y plus 5 is equal to 0. Now, what you are given is C. Ellipse and the two foci. Of course, you might have finished your geometry portion completely by this time. So, this is S and S dash, and you are given that the 0, 3 okay. So, a circle with 0, 3 S at center and passing through the foci. So, that is the circle, right. Zero, 3. Right. First of all, we must know the foci of the ellipse. So, and you know that for standard ellipse x square by a square plus y square by b square is equal to 1, where a is greater than b, or S is equal to AE comma 0 and S dash is equal to minus AE comma 0, where E is the eccentricity E is the eccentricity of the ellipse. Now, and we know that B square is equal to A square into 1 minus C square implies 9 is equal to 16 into 1 minus E square, or that implies that implies E square is equal to 1 minus 16 by 9 by 16, 1 minus 9 by 16, which is equal to 7 by 16. So, E is equal to root 7 by 4. E is equal to root 7 by 4 itself. So, foci are root 7 by 4, is not. So, foci are root 7, 0 and minus root 7, 0. Foci are root 7, 0 and minus root 7, 0. Because, and you know that foci are minus, if you want, I will write this is 4 into root 7 by 4 comma 0. And minus root 7, 0, which is nothing but minus 4 into root 7 by 4 comma 0. Right? So, now radius of the circle is equal to square root of, you get square root, radius of circle is equal to 7 plus 3 square, which is equal to 4. This is 3 and this is 3 square root of 7 plus AE. So, this is simply root 7 minus root 7 comma 0 and this is plus root 7 comma 0. So, therefore, you can write required circle equation. Required circle is So required circle is center 0 comma 3, x minus 0 whole square plus y minus 3 whole square is equal to 4 square radius, or that is x square plus y square minus 6x 9 minus 16. Minus 6y minus 16 equal to 0. X square plus y square minus 6y plus 9 minus 16 means minus 7 equal to 0. So option is answer. Answer is 1. Option number 1 itself. Problem number 8. So this is also given 2013. 13 mains. The circle passing through 1 comma minus 2 and touching the x-axis and touching the x-axis at 3 comma 0 at 3 comma 0 also passes through number 1 minus 5 comma 2 2 comma 5 minus 5 3 5 comma minus 2 and 4 minus 2 comma 5. Right. And you know that the circle passing through 1 comma minus 2 and touching the x-axis at 3 comma 0 also passes through. That means that indicates that the circle is in the fourth quadrant. In the fourth quadrant. Passing through minus 1 comma minus 2. 1 comma minus 2. And touching the x-axis at 3 comma 0. So now suppose the center of the circle is, so this is the radius, okay, that is the radius. So now you can see that the center will be 3 comma some a, 3 comma some a, and a can be minus because it is in the three comma minus a. Now, what is the radius of the circle? The touching the x-axis means the radius is a. The radius is a itself. Okay. Now you can write let C is equal to 3 comma minus a be the center. Be the center. And be the center and where a is greater than 0. A is greater than 0. So that A is the radius. A is the radius. Now you can have that is what is given is x-axis at 3 comma 0. at 3 comma 0 also passes through minus 5 comma 2. So you can have that is x and y axis. So this length is 3. That length is 3. And if you take the center of the circle must be the y coordinate. Y coordinate of the center, the radius of circle. Okay. So now here you can write that is, so it passes through this. Now you can write it. Since the circle passes through okay, passes through 1 comma minus 2, we have mod A or this distance between centers, that is we have 3 minus 1 whole square under square root, that is plus 2 minus a whole square is equal to the radius of the circle is equal to a square. Sorry, radius of circle means a, or that is 4 plus 4 minus 4a plus a square is equal to a square. So a square will cancel. So 4a is equal to 8 or a is equal to 2. A is equal to 2 itself. This is. So a is equal to 2. So therefore, the center is 3 comma minus 2 and radius 2. So therefore, equation of the circle you can have that is. So therefore, equation of the circle is x minus 3 whole square plus y plus 2 whole square is equal to 4, or that is x square or square. So it also passes through, see, you put which is satisfied by so 5 comma minus 2. 5 comma minus 2. So 5 minus 3 whole square means 4, minus 2 plus 2 0 is equal to 4. 5 comma minus 2. So answer is, therefore answer is option number 3.